Welcome back to The Explainer. Today, we're diving into something that quite literally dictates our daily comfort: home climate survival. If you live anywhere with extreme weather, you already know that keeping your place perfectly heated or cooled isn't just some luxury, it is an absolute necessity. We're going to use the unique, wild environment of Wauwatosa, Wisconsin, and some solid data from local experts at Choice HVAC Milwaukee as our lens to totally demystify the science of home comfort. Let's get right into it. So, ask yourself, is your furnace actually ready for a Wisconsin winter? It's a critical question to throw out right out of the gate, because let's face it, seasonal anxiety is very real. When the temperature suddenly plummets at midnight, or the humidity spikes out of nowhere in July, a failing HVAC system instantly goes from being a minor inconvenience to a full-blown emergency. Okay, here is our roadmap for today's explainer. 1. Extreme weather challenge. 2. Historic home issues. 3. Common system failures. 4. Diagnosis versus guesswork. And finally, 5. The three-step process. Starting off with Section 1, Extreme Weather Challenge, Wauwatosa's hostile climate. To really understand why these systems break down, we first have to look at the battlefield they're fighting on. And one glaring number stands out here: 100. We aren't just talking about a pleasantly warm afternoon. We're talking about brutal 100-degree summer heat indexes, pushed to the absolute limit by intense humidity. Combine that with winter temps dropping way below zero, the true joy of the Midwest, and your dormant HVAC system is suddenly forced to wake up and work serious overtime. That dramatic on and off cycling, it is incredibly stressful on mechanical parts. And it isn't just the temperature itself wreaking havoc on a home's infrastructure. That constant freeze-thaw cycle we see in southeastern Wisconsin literally causes your home's ductwork to expand and contract. Over time, that rips open seams and creates massive air leaks. Plus, you've got the region's clay-heavy soil leading to foundation settling, which misaligns those duct systems even further. Bottom line, all of this forces your equipment to work twice as hard just to push air through a leaky system.
Moving right along to Section 2, Historic Home Issues, Architecture versus Airflow.
Because hey, it's not always just the weather fighting your HVAC. Sometimes the house itself is the enemy. On one hand, you have mid-century 1950s ranches. These often have furnaces and ductwork shoved right into tight crawl spaces. That design traps moisture like crazy, leading directly to rusted parts and mold. Compare that to older historic bungalows, like the ones in Washington Highlands. Built way before modern insulation standards, they often rely on aging radiator or boiler systems, and if they have been retrofitted with forced air, they usually suffer from wild two-story temperature imbalances because the original ductwork was grossly undersized. So with all these crazy architectural variables, you absolutely cannot just guess what size furnace or AC a house needs. Enter the manual J-load calculation. This is a precise mathematical method to figure out the exact capacity required. It factors in everything: your window area, your pre-modern insulation levels, even the orientation of the house. Oversize the unit, it short cycles and fails to dehumidify. Undersize it, it runs non-stop without ever actually making you comfortable. Sizing this equipment is a hard science. No guesswork allowed. That brings us to Section 3, Common System Failures. Let's start the breakdown investigation. Now that we know what we're up against with the weather and the homes, let's investigate the actual breakdowns. Cracked heat exchangers. From those repeated heating and cooling cycles, metal fatigue sets in and causes cracks. Let me be clear, this isn't just an efficiency problem, this is a deadly failure. Those cracks allow combustion gases, specifically carbon monoxide, to mix directly into the breathing air of your home. If you ever see yellow burner flames instead of blue, or you spot excessive rust inside the cabinet, that is a massive red flag. And here's the harsh reality: you can't safely repair a cracked heat exchanger. It requires a full furnace replacement, period. Then we flip to the summer side of the equation. Ever wonder why indoor AC coils freeze completely solid during high humidity heat waves? Well, it usually comes down to a few root causes. We're talking restricted airflow from a totally filthy filter, closed or blocked room registers, a failing blower motor, or low refrigerant, which usually means you've got a leak somewhere. When that airflow drops, the coil temperature plunges below freezing, condensation turns to solid ice, and boom, your system's compressor can be permanently damaged. Thankfully, the easiest way to prevent these airflow disasters is entirely in your control. Got a standard 1-inch filter? Swap it out every 30 days. Those thicker 4 or 5-inch filters? Every 90 days. And if you have pets constantly shedding hair and dander, you really need to be doing this every single month. A clogged filter is literally the fastest way to suffocate your system, force it into overdrive, and completely skyrocket your energy bills. Okay, let's move into Section 4, diagnosis versus guesswork, finding the root cause. Identifying a problem is one thing, but how does a true professional actually solve it? Honestly, way too often, the industry standard is just frustrating guesswork. Throwing parts at symptoms, trial and error, basically just assuming what failed. But accurate diagnostics? That means bringing out the meters and gauges. It means physically measuring the airflow, checking the exact refrigerant pressures, and testing the electrical loads and safety switches. You should be paying for permanent solutions, not funding someone's trial and error experiment. Now, when it is actually time to replace a system, you're going to hear a ton of jargon. Let's de-jargonize a big one, the SEER rating. That stands for Seasonal Energy Efficiency Ratio. Think of it like the miles per gallon rating for your air conditioner. Higher numbers mean lower operating costs. To ensure a baseline of efficiency, local codes in places like Wisconsin actually require a minimum of 14 SEER for split systems. And to guarantee those efficiency ratings actually hold up in the real world, strict compliance is absolutely key. Professional installers have to pull mandatory local permits. They must use EPA-certified procedures for handling refrigerants, which is super important as older stuff like R22 gets phased out. They have to ensure proper pipe sizing and venting to keep you safe from carbon monoxide. And finally, they've got to verify that the airflow perfectly meets the design specs. That is exactly how you make sure an installation passes inspection the very first time. Finally, we arrive at Section 5, the 3-step service process, clear solutions. We've covered the elements, the architecture, and the diagnostics. Now let's look at the concrete resolution. This is a brilliant, frustration-free process that prioritizes absolute transparency. Step 1, schedule service. Step 2, diagnosis and approval. Step 3, completion and testing. It sounds simple on paper, but the execution is what truly sets a professional operation apart. Let's break down Step 1, schedule service. Listen, when your furnace completely dies at 2 a.m. on a Sunday, empathy and speed are the only things that matter. You want real people answering the phone. You want specific arrival windows, not someone making you wait around the house all day. And most importantly, you need trucks fully stocked with common parts from major brands like Carrier, Lennox, and Trane. That way, a midnight emergency gets a same-day fix, not a "we'll have to order the part" excuse. Moving on to Step 2, diagnosis and approval. This is all about getting an honest assessment with zero-pressure tactics. Good technicians will physically show you the failed part, like, say, a locked rotor on an AC compressor, and explain why it broke in plain, everyday language. If an 8-year-old AC needs a $400 repair, they should compare that cost against a total replacement and let you make the call. You get a written estimate in your hands before a single wrench is even turned. Then we have Step 3. Completion and testing, because the job just isn't done until it's been thoroughly tested. Whether it's a quick minor repair or a massive new installation, pros verify proper system operation, check that the airflow is perfectly balanced, and confirm safe combustion draft testing before they ever think about backing out of your driveway. So if you take away one crucial point from this entire explainer, it really boils down to this core philosophy. Transparency builds trust. We explain what failed, why it failed, and what options exist. Having the facts makes for an informed decision, and that's the best decision you can possibly make for your home's comfort and your wallet. No inflated quotes, no guesswork, just straight, honest answers. Which leads us with one final, provocative question to really challenge our own complacency. Is your HVAC system actually safe, operating efficiently, and truly ready for whatever extreme weather is coming next? Or is it just barely surviving the season, waiting to completely fail on the coldest night of the year? Seriously, don't wait for a 2 a.m. breakdown to find out. Check your filters, schedule that maintenance, and demand transparency from your local professionals. Thanks for joining me on this explainer, and stay comfortable out there.